Welcome back to Lesson 10 of HSC Silicon Valley's Python lessons. I'm your instructor, Jason Shim, and today we'll be talking about, various modules that you might find some good use of in Python. So to review, modules are just imported groups of functions, variables, and other objects that you might want to have in your code. And so you just have import and module name if you want to ever import them. And functions, you call them as functions. So today we're going to go through 6 different modules. The copy module, which we can use to make copies of objects. The keyword module, which we can use to, look for keywords. And the random module, which is extremely useful for random number generation. The sys module, which is, again, extremely useful for controlling the shell, which is the Python console. The time module, which may seem straightforward. Obviously, it gives the time, displays the time, but it also has some pretty interesting applications because of how it's designed, which we will get into in due time. And finally, the Pickle module, which we use to convert Python objects into readable files. So without further ado, let's jump right into this. So to start, we have the copy module. Again, this module contains functions that we can use to create copies of objects. And let me demonstrate how that would be useful. So let's start with a class. Let's call it animal. I don't know, making things up. Do this. So it would be self dot. Let's have species, number of legs, and color. So self dot species, that would be species, and color. Hold on, let me copy and paste this. Self dot number of legs equals number of legs, and self dot color would again be color. Whoops, I'll do that. Self dot color. Excellent. Now let's create a new object in this class. I don't know. Let's go with Zaboomafu, the ever adorable lemur. So we call the class animal, and with the arguments, he would be a lemur. Number of legs, I believe that would be 4. And color, let's just put black for now. I am aware that they are black and white, but let's stick with black. Now, what if we wanted multiple lemurs and lemur objects, lemurids? For instance, Morris, the lemur. Let's throw in Chester. Now, we could do that, or we could, instead of repeating this over and over, we could use copy, which is found in the copy module. So let's go ahead and import copy. Fantastic. And comment this out. Comment that out too. And instead of just repeating all of this, as I have just done, we could Morris could be just copy of Zaboomafu, because we've already created that. And so let's test this out. Let's print Zabufu.species, and we can also print Morris.species, and let's compare them. Run. Oh, sorry, I would have to save this. Or not. Apologies. Yeah, give me a second. So, even after I've named it, it's saying this constructor takes no argument, and this is actually because we didn't do the double underscore. So, if I do that now, yeah. So now you can see that both outputs of lemur are coming out, so we can confirm that these are the same. And just to test it out, if you put, say, number of legs, I'm sure they'd be the same. Yes, both 4. And color, for sake of black and black. So in this example, we create an object and we label it with the variable, Zabufu, and Morris would be the copy of that object. And like, sure, this only saves a bit of typing, but when the objects are more complicated than just this, it becomes a lot more useful. Lists count as objects, so let's do lists. Fun. So let's actually create. Hold on. Whoops. No. There we go. Let's actually revive these. And let's say that Morris and Chester. Forgot to Chester. But let's say that Morris and Chester are non-leaders. They've changed their minds. They want to be. Well, Morris wants to be a chameleon. Still 4 legs, and you would be a green. But Chester, he wants to be an emu. I'd give him 2 legs, and I don't know what color emus are. I'll assume it's black. Really? They're like brownish. Let's not get hung up on that. We can go ahead with that list. Why not? Let's call it my animals. Square brackets. Zabufu, Morris, and Chester. Excellent. So let's just make a copy of this list. I think that's where we were going. Why? Your animals is the obvious. Is the obvious other name. Copy.copy, and we would do that of my animals. And let's try it out. Print. Well, we already know the animals on this list, so all I need to do is do this one. Actually, no, here's an idea. Let's do 2 prints, but they're 3 prints, why not? But they're of different items in that list. So we must remember index numbering. So 0 would be 1 and 2. 1, 2 would be, sorry if that's confusing. But we did go over that in our lists and arrays video. You should check that out. But let's test this out. So we know that we have Zabufu, Morris, and Chester. They're lemur, chameleon, and emu. And yeah, we do get this. delightful. And just for sake of necessity, black, green, black. Amazing. So, right, we let's look at this code a bit. We create 3 animal objects. We store them in Zaboomafoo, Mars, and Chester. And then we add these objects to a list, and then we copy that list. And finally, we print these to make sure that they're correct. So instead of having to create the objects within these lists over and over again, we can just copy a list, which is ultra convenient. Now, if you looked at the copy module slide before, and I'll show it here again, you might notice that I have addressed that copy.copy, this thing over here, creates a shallow copy. And I have defined that as changing when the original object changes. And so actually, let's just go out and check this property out. So let's try changing it down over here instead of like changing it like here. Let's change it in the code. So let's have my animals. The first animal, not species. Let's make that something different. Like, let's say Zaboomafoo has had a change of heart. Instead of becoming a lemur, he'd much rather be, I don't know, like a beluga. And, well, actually, no. Let's ultra convenient. Oh, I'm sorry. Species. Yeah, now he's a beluga. Intriguing. And this is what I meant by shallow copy. You can see that it changes when the original object changes. So let's so if we add like a new animal to the first list, it won't make it won't appear in the copy. And so it's interesting because the new list doesn't have its own new objects. Like let's go up here. Your animals would have like the same 3 objects inside it. Like we've established that. So actually, let's instead of doing this, let's now tinker with it by what's another name? Herman. And now Herman, he would be an addition to this. Addition to this class. Let's say he would be some kind of a mongoose. Yes. 4-legged again. And what color is a mongoose? Let's just say orange for now. Probably brownish. And let's append this to my animals. So my animals dot append Herman. And so now instead of this, we can print len my animals. Len would be length. And we can make that your animals. And oh, sorry. Yeah, you can see that they're actually different lengths. So it's not added to the copy of that list. It's copied because yeah, it's copied before we actually have that. I hope that makes sense. And now there's also a deep copy, and this creates copies of all objects inside the object being copied. And so we will right, sorry for losing my train of thought there. Let me uncomment this, and let me comment this, because it won't be very helpful. Let me re-comment, sorry. Re-uncomment this. And so, let's go with, sorry for all the commenting, but if we do copy.deep copy, and make that a beluga, now it should, wait. Sorry. So let's just look at the difference. Yeah, so, your animal copy still recognizes it as a lemur, but the my animals copy knows that it's a beluga. So yeah, that's nice and all. Now let's look at the keyword module. Let me create a file of this. Modules. It's nice to have them organized, although they're in the modules folder, so maybe I shouldn't start them with modules, but anyways. So I'm gonna start blitzing through these a bit, because we have like 6 to go through, I believe. So a keyword, in case you don't know, is a word part of the Python language. So stuff like if, else, or, stuff that the program recognizes, and like stuff that it colors, like class, import, and important stuff like that. And so what the keyword module is that it contains a function called isKeyword and a variable called kwlist. Now, isKeyword returns true if a string is a keyword, and kwlist just returns a list of keywords. So a pretty self-explanatory module. So let's do import keyword. Let's look at this in all of its functionality, which isn't a lot, but I'm sure this could be useful if you wanted to. So I don't know, man. If let's look at this. True. Amazing. Now to prove that false. Amazing. And what if I did print keyword.kwlist? What would I get? Oh, amazing. I get this whole list of Python keywords. And you can probably find the description of each keyword somewhere online. So that's nice to know. Next, I told you we are going to blitz through these, except with some of them. We are doing the random module now. Yeah, sorry, I started to ditch the modules. Random.py. So the random module, as I said before, is all about generating random numbers. It includes, well, not always numbers actually, as we'll soon get into, but it includes the functions randint, choice, and shuffle. So let's see what they do. Import, apologies, import random. So let's look at random.randint first. So this actually picks a random number from a range. So let's say we're going 1 to 100, and we want to print a random number here. Sorry. What? No attribute ran. Oh, my mistake. Rand int. Module object. No attribute rand int. Hold on. Let me try troubleshooting this real quick. So the problem is in line 3. So I found out what's wrong, and it has to do with the name of our file. As soon as I ditch modules, it comes back to bite me. Sorry if you heard that in the background. So what we need to do is rename this as soon as possible. Rename this to modules random.py. File open. Don't think we need that. I do trust the authors of these files. Okay, nice. 37, 54, 67, 72. You can see that this is just random, entirely random. Let's go big. Ooh. Lots of randomness. So, yeah, that's pretty much the point of this. Let's start messing around with this. Like in games, you know, you have RNG as a central component of many games. And let's just try to mimic that, because that's kind of fun. I don't think I really need to comment this, but... So let's say a number, and we have... Hold on. And we have that as our function right here. Actually, now that I'm thinking about it, it might be nice to make a small game. A small infinite game, while true. Sorry, forgot the colon there. And we'll have this be a simple text-based adventure. Guess a number between 1 and 100. And we have guess be the input inside of the shell. Yeah, I think that's fine. And I guess we have an arbitrary variable of I, and that's the integer that's put into the guess. I hope this is making sense. And so now we get to use some fun if and else if statements. So if I is exactly equal to the number, oops, semicolon, I guess we can print correct. You win. And then we can break this. But if that's not true, and we use elif because it can like carry over, print guess a higher value. And we can replicate this. Ooh. Yeah, so we just do it with greater, guess a lower value. So I hope you can understand this. So oh yeah, let's try this out. Between 1 and 100. The tactical guesser. Let's go with 50. Oh. Actually, yeah. Let's make that a feature. So guess a lower value. I'll need to guess something lower. Again, tactically 25. Guess a higher value, so we know it's in between 50 and 25. So I guess in the middle of that would be plus 12.5, 37. So it still is higher. And so we keep on dividing by 2. Maybe it's dragging on a bit, but I believe the next is 6 point something. I'll round it up to 44. Guess higher. So now we've narrowed it down to between 44 and 50. And 47. Guess a lower value, so now it's between 47 and 44. I guess we just do 40s. Yay! Amazing. I have won. So that's a fun game. Let me just comment all of this out. There we go. Nice and commented. So we have to actually get into the other functions of the module. Sorry, I kind of wanted to blitz through this, but I got a bit sidetracked. But that must have been fun. So, choice. Choice actually picks a random item from a list. So yeah, let's just create a list. I might just steal. Actually, no, that won't be very useful. Desserts equals. Actually, no. Let's just do deserts. Let's see. We have the Taklimakan. We have the Sahara. We have the Gobi. We have Nairobi. Antarctica. These that count. Oh, I am sorry. Yeah, let's end it off there. So let's say we wanted to, for some reason, choose a desert to go to. Shocking. We would just do print.random.choice deserts. And less than that. Oh, okay. Amazing. We get to go to the Nairobi desert. I will appreciate that. But that's pretty much the entire use of choice. There's also shuffle. Actually, let's use the same list. Random dot shuffle deserts, and we want a way to see the order. So Prince deserts, and yeah, you can see that it's a vastly different order. Reorganizing randomly my bucket list. But yeah, that's pretty much all we have for random. Now we get into the more meaty ones, as if that wasn't meaty enough. New file. Select a language. Python. I should really set that to my default. Modules underscore sys. Now, sys, as I said before, lets you control the shell. And it has a bunch of functions and objects and variables to help you out with that. We'll just be looking at 4 of those. So, as always, import sys. and the first one we're doing is exit, and this just amazing, it has been exited. And it's kind of a way of stopping the Python shell, and it's just shut down. Yeah, not much else to say. So we also have the objects Stdn and Std Out. So, and I believe this is just, it prompts a user to enter information to be read into the shell and used by the program. So yeah, let's just do it. A equals sys dot, no, I'm feeling a bit more descriptive today. Sys dot stdin dot readline actually no, and let's have that printed, and print input. Actually, do I really want to do that? Wait, sorry. Yeah. So I put in epic, it prints out epic. Quite epic. And you might notice that, actually, no, there's, it's a bit ironic that I made this input because there's also an input function, but the readline function is a bit different because you can actually specify the number of characters to read as a parameter. So let's actually have 13 as a parameter. And so let's just sus space, that's 4, among, that's 5, so we have 9, us, 12, sussy, and so, yeah, it just cuts all of this garbage out because 13 characters is the max. Cool. We've gone through exit. Useful when you want to like break. We have stdn. We can do std out. So let's just say sys.stdout.write. And here we would put a string. And so this is pretty much the same as print, right? It's it writes messages to the shell. But it's interesting because it's a file object, so it has the same functions that it has like the write function and stuff like that, and it will also return the count of the numbers. Sorry, the number of characters that is written, and so we can actually save that. So it's not just printing, in a way. Like 9 plus 10. Wait. So I don't believe it's quite displayed, but you get the picture. And finally we have the variable version. And this is again just print sys.version, bam, we get the version. Amazing. Yeah, that's the end of the sys new file. Select a language, Python, modules, time. So the time module is interesting, more interesting than just displaying the time, because we can see this with our first function, and conveniently it's called time. Print time.time. What is this number? Well, it's like the number of seconds since January 1st, 1970. And that's an interesting reference point. I believe the computer uses it, actually. It's the earliest date. Like, ever noticed that when you try to scroll back on an age thing, it goes back to 1970? And yeah, that's why. So, like, this might not seem incredibly useful, because, well, it's a reference point that you're not going to use. But I assure you, there is a use for this. It's called subtraction. So let's create a function. Def lots of numbers. For x in range of 0 and the maximum, we would print x. And so after that, let's actually call the function. 1000. And we would have to work out how long the function actually takes. By modifying our program with the time module. So I guess we would edit this a bit. T1, the first time. We would call that. And then we would do that. And then after that we would do T2. And that's the second timestamp, if you will. Actually, hold on. And after this, as part of the function, as part of the function, you would just want to print it took seconds. If you remember, this was it allows you to slot in stuff with stuff. Yeah. So let's do this. It took a surprisingly short amount of time to count to 1000. But yeah, there you go. An actual use for January 1st, 1970. So I hope you understand how this works. I will try to explain it now. So we take a snapshot of like the seconds, right? Since it's from a reference point. Normally this would be like where you start your stopwatch. And then you do this fun stuff. Here it's 1000, it could be anything. And then after you're done, after like you're done going through this for loop, you would take another timestamp. And then after that you would subtract the first timestamp from the second one. And then by doing that you would figure out like how many seconds you have, right? So yeah, that's cool. Know what else is cool? Ask time. And you might be wondering what that is. That is another function, except it makes like the time actually readable. Instead of a bunch of seconds from an arbitrary reference point, we can, we can just print time.ask time. And yeah, we get, oh god, it's that time already. But yeah, jokes aside, we do get this. So to use a parameter with this function, we have to actually create a tuple. Tuple equals, let's just say the year is 2021. And it's February 31st. Like, but I don't know. This would be the hour, if I'm not mistaken, and this would be the minutes, and wait. Actually, let me just slot in random variables. So this is year, this is month, this is day, this is hours, this is minutes, this is seconds, and then we have day of the week. Like 0 would be Monday, 1 would be Tuesday, and so on, because it's index counting. Oh, we actually have more. We have day of the year. Sorry, day of the week and day of the year are different. I'll put 0 as a placeholder. And whether or not it's daylight saving time. So 0. This stuff is complicated. And then let's just put in tuple as a parameter. An argument. And yeah, it's February 31, 10/20, the 7th second of 10/20 at 2021. Amazing. So why did I import time again? We have two other functions to go through. We have local time, like print time.local time. And this is a bunch of slightly more readable stuff. But the actual importance of this is that it returns it as an object. Yeah. I am pretty sure the values are actually in the same order as the ask time, so that's pretty useful. So as with the tuple of ask time, we can use the index positions in this object to print like whatever we want. So the year and month, let's say. So if we have TB, the time.local time, the year be the first, this, month be the second, and then we print the year, and whoops, we print the month. Because we know that year is in the first position, position 0, and month is in the second position, 1. And so this theoretically should work. Invalid syntax. Huh? I'm not quite sure I understand. What did I do wrong? Sorry, let me troubleshoot this. I'll be right back. We are actually, I'm not quite sure what the issue is here. It's being a bit untransparent, but it's supposed to display the year and the month. So, yeah. The final function we have to go through is sleep, which is something that I need to do. It's useful because it helps you delay stuff. Like, it suspends the program. So, for instance, if we have, if we have some for loop of like 1 and 100. Sorry if that's not visible. This is not helping. 1 and 100, and then we just printed X. What would happen? What? How is X invalid syntax? Is there a difference between, yeah, I'm not really sure why it's not recognizing print as legitimate. Again, guys, sorry if there's background noise. I don't understand why this isn't being recognized. What is so invalid about this? What? Oh, I am so sorry, guys. Well, let me sort this out. Sorry, it's not, I tried it on, other, consoles and it seems to work. It's just this one in particular doesn't recognize it as valid syntax, which is extremely puzzling. But the point is that if I were to put time.sleep for like 1 here, that'll add a delay in between. It would add a delay. Right, it's not working for reasons beyond my control. But yeah, that's the idea. Sorry, I sincerely apologize that I couldn't actually display this. And finally, we can do the Pickle Module. I'll have to pray that it works because nothing else is working for me today. Modules. Pickle. Yeah, let's hope this works. So what the Pickle module does is that it converts Python objects into a format which is file friendly, which you can write and read back and dump into a file. Fittingly, there are 2 major functions in the Pickle module. We have the dump function, which pickles the data into a file, and the load function, which unpickles the data from its file. So yeah, you might want this in some sort of game, where you might want to save information about a player's progress. So yeah, let's try to mimic a save state. Game data where we have player position, and that would be some coordinates. Let's make things up, and 71, and E39. I'm sure that would indicate some sort of thing elsewhere. For inventory, we'd have diamonds. Sorry, this would be a list. Pickaxe, apple, and thus forth. Oh, sorry, I am forgetting the commas. My mistake. We'd have, I guess, money. Like, I don't know, some arbitrary amount. Yeah. So here's our game data. We just import pickle, and I'll have to open this. And then we would call pickle.dump game data save file. Sorry. And then we do save file.close. So let's run through this. We import the Pickle module. We create a spoof of some game data. And then we open the file save.dat with the parameter wb, which that tells Python to write it in binary. Right, like you might need to save it in some directory, and then after this we use dump, which, if you remember, pickles the data into a file, and so that passes in the map in the file variable. That's right, as two parameters. And finally, we close the file because we're finished with it. Again, the shell seems to dislike me, but I guess it's worth trying to unpickle this. So we had the load file equals open. Hold on, let me just copy this. Load, so save. Load file. This would end with load file.close. So we're pretty much reversing this, as you can tell. We take the information right into the file and convert it back into values that our program can use. So we'd go loaded game data equals pickle.load load file. So what we do here is we open the file using RB as a parameter. Oh, sorry, I meant to put RB, which means read binary as opposed to write binary. That's WB. And then we pass the file to load, and we set the return value to the variable loaded game data. And so what the load function does is it unpickles the data from its file. It's the opposite of jump. And the console has been treating me well, but now we should print loaded game data. And if the console, yeah, I am so sorry. I really don't know what's going on. This is the first time that the console has decided to just absolutely reject me. But now, yeah, that's pretty much the end of this lesson. I'm sorry that not everything worked out, but this should display everything in the game data. Evidently didn't, but I hope that you have learned something today. And this is the end of HSC lesson 10. Yeah, have a nice day.